Have you ever stopped to think about why the operational phase of a building, which lasts for decades, is so often treated as an afterthought during project design and construction? Many project teams operate under the assumption that if they simply focus on completing the immediate build, the operational data will take care of itself. Welcome to Module 1 Foundations, Lesson 1.2, where we focus on the information life cycle, asset versus project information management. In this introductory section, we are going to explore the core architectural reason why the operation, and not the short-term project, must always define exactly what information you need to produce. Over this approximately 22-minute beginner session, aligned to parts 1 and 3 of the ISO 19650 standard, we will challenge the traditional project boundaries that cause structural data loss. By the end of this session, you will understand how to view data as a continuous stream that outlives any single construction contract. Let's move into our first core operational challenge and look at the real price of bad handovers. Let's talk about an invisible financial leak that plagues modern infrastructure owners. The reality that you are likely paying twice for your asset data. A broken project handover forces owners to resurvey their own brand new buildings just to understand what equipment has been installed. This unnecessary expenditure happens because the delivery team optimizes only for short-term project goals, leaving the owner to inherit massive data gaps. Optimizing for the short term means that the operations needs are ignored, resulting in missing asset registries and misplaced warranty documents. ISO 19650 completely fixes this structural failure by forcing organizations to systematically plan the project from the long-term operation backwards. By reversing our planning model, we protect the owner from losing the critical information they have already paid for. Let's establish our explicit educational milestones for this lesson to understand how this is achieved. To establish our technical roadmap, let's review the explicit learning objectives for this lesson. First, we will learn to clearly differentiate project information management from long-term asset information management. Second, we will map distinct information needs across each specific phase of the asset life cycle. Third, we will analyze why operational needs must drive what is produced during the intense delivery phase. Fourth, we will introduce the structural concepts of the Asset Information Model, or AIM, and the Project Information Model, or PIM, exploring exactly how one feeds into the other. Finally, you will recognize the core discipline of foundational information management, demonstrating why the project handover serves as the critical functional interface. Let's begin by defining our two primary management environments. To establish a rigorous data strategy, we must recognize that there are two distinct kinds of information management running across an asset's lifetime: Project Information Management, or PIM, and Asset Information Management, or AIM. Let's break down the parameters of each environment. Project Information Management, or PIM, operates exclusively within the delivery phase, which encompasses design, procurement, and physical construction. The pace of this phase is intense, collaborative, and highly time-boxed, culminating in a definitive endpoint known as the handover. The immediate customer of the PIM is the delivery team itself. In stark contrast, Asset Information Management, or AIM, operates within the operational phase, where the asset is actively operated, maintained, and used. The pace here is continuous and steady, stretching across decades-long timelines until the asset reaches its ultimate renewal or end-of-life cycle. The customer for this model is the owner or operator. You must internalize this absolute rule. The first environment exists solely to feed data into the second. Let's map this unified data flow across the complete lifecycle loop. When we map out an infrastructure asset from birth to death, the entire lifecycle must be treated as a single, unbroken information flow. This lifecycle wheel spins continuously through 6 major milestones: strategy and brief, design, construction, handover, operation and use, and finally, renewal or end of life. Image showing the circular asset lifecycle loop, highlighting delivery phases connecting to operations via handover. Let's look at 3 critical lifecycle rules that must govern your data design. Rule number 1. Handover is not the end of the line. In real financial and value terms, it represents roughly the midpoint of the asset's total lifecycle journey. Rule number 2. Assets are built only once, but must be maintained for 30, 50, or even 100 plus years. Rule number 3. Information must be structured from day one to serve this long tail of operation, rather than just serving the noisy, short-term needs of the delivery phase. Let's look at how this impacts your planning direction. Let's contrast 2 fundamentally opposed approaches to project data planning to understand how ISO 19650 changes our engineering workflow. The traditional flawed approach allows the delivery team to produce whatever information their design software tools naturally output, hoping it will somehow be useful to the client later. This lack of planning results in a bloated, unsearchable model that the facility management team cannot utilize. The disciplined ISO 19650 approach reverses this dynamic entirely by starting explicitly with what the asset operation will need and working backwards from that endpoint. In this framework, needs and requirements flow down from asset operation to project delivery. Then, as the project progresses, the structured information models flow back up to cleanly serve the operational end. Let's look at the specific documents and acronyms used to enforce this flow. To structure this workflow mechanically, the standard creates a clear division of labor. Requirements specify the needs, while information models hold the resulting data. Let's examine this structural relationship by mapping our requirements documents directly to our delivered models. On the requirements side, everything begins with the high-level Organizational Information Requirements, or OIR, which capture the corporate owner's business needs. These corporate needs distill down into the Asset Information Requirements, or AIR, which define the specific engineering data required to run the facility's equipment. For a specific construction intervention, these inform the Project Information Requirements, or PIR, and the Localized Exchange Information Requirements, or EIR. These requirements documents on the left flow down directly from the owner's needs. On the right side, our information models capture and deliver that data back up to serve the operation. The Project Information Model, or PIM, accumulates data during delivery, and the verified parts are then transitioned into the Asset Information Model, or AIM, to support active operations. Let's trace the complete step-by-step chain of information from inception to final delivery. Let's walk through the complete information chain to understand how a high-level corporate need translates into a specific, tangible project deliverable. The flow begins with the Organizational Information Requirements, or OIR. This document directly informs the Asset Information Requirements, or AIR, which capture specific equipment needs. Together, these feed into the Project Information Requirements, or PIR, to define the project's parameters. The PIR then shapes the Exchange Information Requirements, or EIR, which are embedded directly into procurement tenders. Once a contractor is selected, they respond with the BIM Execution Plan, or BEP, which details their technical approach. This execution strategy is operationalized via the Master Information Delivery Plan, or MIDP, which lists every single project deliverable. These deliverables are then authored, checked, and stored within a managed software environment known as the Common Data Environment, or CDE. Finally, this rigorous pipeline outputs the final PIM and AIM. You must remember this critical warning. Every single link in this chain must remain intact. If a single link breaks, the final model will completely fail to serve the operational facility. Let's look closer at the unique characteristics of the delivery phase. To manage data effectively, you must understand that the delivery phase and the operational phase run at completely different speeds and are governed by separate parts of the international standard. Let's look at this comparison table. The delivery phase is governed strictly by the clauses in ISO 19650-2. It is strictly time-boxed with a clear calendar start and end point. Its primary goal is to assemble the Project Information Model, or PIM, and its immediate customer is the project appointment or contract structure. This phase ends abruptly at the handover milestone. During this intense period, the delivery team produces the PIM collaboratively, using rigorous quality control to check and validate all information before it is shared or published. Let's contrast this with the steady state of the operational phase. Once handover is complete, the asset transitions into the operational phase, which represents a steady state of foundational information management governed by ISO 19650-3. This phase begins immediately at handover and runs continuously for the entire remaining life of the physical asset, focusing on maintaining and protecting the Asset Information Model, or AIM, image showing the unbroken thread of foundational information management spanning various lifecycle triggers like refurbishment, new tenant, and plant replacement. Think of foundational management as the owner's ongoing baseline management of asset information between major capital projects. As the physical asset changes over its life cycle due to operational triggers such as a building refurbishment, welcoming a new tenant, or executing a plant equipment replacement, the AIM must be kept current. Here is the real-world reality. Without a properly maintained operational baseline, every subsequent project will start from degraded, untrustworthy data, forcing you to pay for expensive resurveys over and over again. Let's examine how contractual accountability is managed across these phases. Passionate discussions about data architecture mean nothing if your contracts do not explicitly define who owns the accountability for accuracy. Under ISO 1965 terminology, accountability flows through three strictly defined layers of appointments. At the absolute top sits the appointing party, which represents the client or asset owner. They are responsible for ensuring that clear information requirements flow down to the market. The next layer is the lead appointed party, which manages the delivery team and is typically a Tier 1 contractor or lead design firm. They pull together data from the various appointed parties, which represent the specialized task teams and subcontractors authoring the data. As these task teams build out their containers, the information flows back up the chain to the client. Handover represents the critical contract boundary, where formal legal and technical accountability is transferred from the lead appointed party back to the owner. Let's look at how to design this handover interface effectively. A successful project handover must be engineered from day one of the contract. It can never be improvised at the end of construction. Let's directly contrast a badly managed handover with a world-class ISO 1965 handover to see the operational difference. When handover is done badly, unstructured PDFs and random instruction manuals are dumped on the owner at the last minute. The owner is forced to spend massive resources resurveying the building to figure out what they actually own, and data must be manually rekeyed by hand into the facility management software. Worse yet, safety and risk knowledge is permanently lost, leaving no verified record of what was accepted. When handover is done well under ISO 1965, structured information is accepted progressively against requirements throughout the project. The owner queries the live AIM from day one. Data flows into operations in a usable structure, safety data is preserved, and the owner maintains a verified acceptance record. Let's look at a concrete example using a new hospital facility. Let's ground these concepts in a concrete example by looking at the development requirements for a modern hospital facility. Under a disciplined framework, the hospital operators define their exact demand before design or procurement even begins. They do not need every single line of 3D modeling geometry or cosmetic detail. Instead, they focus heavily on isolating specific operational data points required for day-to-day healthcare delivery. They ask critical mechanical questions. Which specific air handling unit serves which operating theater? What are the exact filter types and scheduled replacement intervals? Where are the equipment warranties, maintenance logs, and official commissioning data packages? These explicit operational data needs are captured early within the Asset Information Requirements, or AIR, ensuring the delivery team knows exactly what parameters they will be graded against. Let's look at how this changes the opening day of operations. Let's fast forward to the completion of our hospital project and look at how this rigorous planning transforms day one operations. At the handover milestone, the owner does not accept a raw, unverified data dump. Instead, a carefully verified subset of the project information model that directly answers those original AIR requirements is accepted cleanly into the asset information model. Image showing a hospital corridor overlaid with a highly structured, searchable digital schematic of mechanical and plumbing assets. The practical result is extraordinary. On opening day, the hospital's facilities management team can instantly search the digital asset record, plan preventative maintenance, and respond to equipment faults within minutes. Furthermore, as the years roll on, foundational information management keeps this asset record completely accurate and trustworthy, providing a perfect baseline for future refurbishments. Let's look at the failure modes we must avoid to protect this flow. To protect your organization's data assets, you must train your team to recognize the 4 primary ways that information management fails in the real world. Failure mode. Number 1 is a project-only focus, which means planning exclusively for immediate project milestones while leaving the owner to inherit massive data gaps. Failure mode number 2 is the last-minute scramble, where teams treat handover as an afterthought left for the final weeks of construction with no agreed acceptance criteria. Failure mode number 3 is the infamous data dump. This occurs when a team confuses the PIM with the AIM, dumping a heavy, unchecked design model on the operator. Finally, failure mode number 4 is decaying baselines, which happens when an owner completely neglects foundational management, allowing their asset data to decay between projects. Let's look at how the standard structures information movement to prevent these failures. A common misconception is that information should flow in a continuous, unmanaged stream from the design tools straight to the client. This is a recipe for chaos. In a professional ISO 19650 environment, information moves in highly deliberate exchanges that are tied to specific project milestones. At each individual milestone, a precisely defined set of information containers is formally exchanged, verified against the requirements, and formally accepted. This structure enforces a vital management rule. Late but perfect information is still an absolute failure if the critical project decision was already made without it. Data is only valuable if it arrives in time to inform human choices. Let's map out these critical decisions against typical project milestones. To understand how information supports project delivery, let's look at this reference matrix that ties specific information exchanges directly to critical project decisions. At the end of a typical design stage, the decision to proceed with or refine the design layout is supported by exchanging fully coordinated design information at an agreed level of need. At the procurement milestone, the decision to award contracts and mobilize teams relies on exchanging technical information sufficient to support tendering and formal appointments. Moving to construction release, the decision to authorize building on site requires exchanging fully approved and formally published information for construction purposes. Finally, at the handover milestone, the critical decision to operate the physical asset is powered by exchanging a verified asset information package that is accepted cleanly into the operational AIM. Let's examine the software environment that makes this continuous thread possible. How do we make this continuous information thread a managed reality rather than just a nice aspiration? We do it by implementing a common data environment, or CDE. The CDE is the continuous infrastructure thread that spans the entire asset lifecycle across both delivery and operational phases. Image showing an infinity loop representing the continuous thread of the CDE linking delivery to operation. Let's look at how the function of the CDE shifts across the lifecycle. During the delivery phase, it securely holds and controls the evolving project information model, or PIM. At the handover interface, it serves as the formal gate where information containers are systematically verified and accepted. Then, during the operational phase, it holds, updates, and protects the Active Asset Information Model, or AIM. The CDE provides the structural backbone for unified information management. Let's look at how this transforms organizational accountability. Let's summarize why this structural split between delivery and operation matters so much in day-to-day practice. This division of labor establishes clear lines of contractual accountability across the lifecycle. During the delivery phase, the lead-appointed party is contractually accountable for producing and validating information to the exact compiled requirements of the client. Then, once the handover milestone is passed, this accountability formally transfers over to the owner, who becomes responsible for keeping the Asset Information Model, or AIM, current during active operations. Handover is not just a casual transfer of digital files. It is the formal legal transfer of operational accountability. When you enforce this discipline, owners achieve highly usable records, significantly lower operating costs, and zero expensive surprises at closeout. Let's lock in our 5 key takeaways for this lesson. We have reached the conclusion of our session on lifecycle information flows. Let's review our 5 key takeaways to ensure these concepts are locked in. First, project information management ends abruptly at handover, while asset information management lasts for the entire operational life of the built asset. Second, the PIM is built during delivery under Part 2 rules, and verified parts are then accepted into the AIM under Part 3 rules. Third, because the vast majority of an asset's total value and financial cost sit within the operational phase, you must plan your information frameworks to serve that long tail. Fourth, you must always specify your data requirements from the operational end backwards. Finally, fifth, handover must be engineered from the start and checked rigorously against the asset information requirements. Let's run a quick knowledge check to validate these takeaways. Let's close this session with 3 quick questions to check your understanding of today's concepts. Question 1. The Asset Information Model, or AIM, primarily supports which phase? The choices are the design competition, the operational phase of the asset, software licensing, or tender evaluation. The correct answer is B, the operational phase of the asset, because the AIM is designed specifically to support long-term operations. Question 2. ISO 1965 advises that information requirements should be driven mainly by what? The choices are whatever the software exports, design lead preferences, the needs of the operational phase worked backwards, or the contractor's tooling. The correct answer is C. We always work backwards from operational needs. Question 3. At handover, what should be accepted into the AIM? The choices are the entire project model unchecked, nothing, the verified subset of the PIM that the operation needs, or only 3D geometry. The correct answer is C, as we only pull forward the verified subset that supports operations. This completes our lesson. I will see you in our next session.